Okay, guys, we can start. So, yeah. So, good afternoon, everybody. First of all, I sent you an email about the time and location of the final exam 2 times. I want to make sure you know it, okay? So, we're going to meet here in this room, 3:30 on Friday, right? So as I told you, maybe I'm not sure if I said it before or not, so I'm going to repeat it. In the final exam, I'm going to give you 2 questions, okay? One question in C, the other one is going to be in assembly. I'm not going to give you the choice, so I'm going to ask you to do this one in C and this question in assembly, okay? Every question is going to be application, okay? So application, like, for example, like test 2, but for sure, I'm going to consider it's not going to be that big, okay? So how can you prepare for the test? The way you have to prepare for the test, guys, is if you want to, for example, if you should know how can you use the LCD in C and assembly. Is that you should know that, okay? So that if I give you in the application, it's either C and assembly, if I tell you in the application, you have to write this message on the LCD. You should know how to do it, right? If I tell you, for example, if a certain value is greater than 50, for example, energize the buzzer. You should know how can you energize the buzzer. You understand what I'm saying? So you should learn these small pieces, okay? How can you use? That's what I taught in this course, right? How can you use IRQ? How can you use RTI? All of these things, okay? Usually, you know, the exam is open book. You should not use electronic devices, okay? Because it's open book and you already have the slides. So that's why the exam is going to be long, okay? Because I have to make some balance, right? I cannot make it short and open book. So it's going to be somehow long, okay? So you have to be prepared. How can you be prepared? As I told you, you should not think. If you want to use the 7 segment, you already know how to use the 7 segment, or you already prepare the slide. You know where you are not going to have time during the exam to look for where is the 7 segment and then understand the slides during the exam. You're not going to have time to do that. Is that okay? Anyway, it should be very easy if you already understand this course. It should not. But again, the challenge may be in the time. So it's going to be long because again, it cannot be short and easy. It's going to be so anyway. So it's going to be easy, but maybe you're going to have some challenge in the time. So you need to be ready. Okay. Anyway, so this is one thing. What else? Okay, I think we can start. We can start today. Yes.
Do we have class on Wednesday?
Yeah, I guess. Yeah, right. We should have class on Wednesday, right? No, it should not be during the session. It should not be during the lecture time. It should be outside the lecture time. Okay, no, that's a mistake from the TA. So I'm gonna talk to the TA about this. Okay, so we're gonna, yes, so we're gonna have a lecture on Friday as normal. Yes, yes. No, that okay? Okay, just make it easy. I'm not gonna put it in the test. Okay. Now let's start. And also I'm gonna tell you here in this chapter, because this chapter I started it late, so I'm gonna tell you what exactly we need from this chapter. Okay. Anyway, so in this chapter, as I told you before, nothing is new, as you will see right now. Okay. Regarding programming, nothing is new, because for programming, all what we have to do is just to register. You have to do configuration as we did before. Also, we have a number of interrupts. You already know from what we did before how can you use interrupts. So programming wise, you are not going to see big difference here. Okay. Yeah, so sorry, before I forget, one important thing, guys, is I think there is a deadline for the evaluation of this course and other courses, okay? Actually, what happened since we moved from paper evaluation to online evaluation, the number of students who evaluate all courses, okay, dropped significantly, sometimes 17% to 20%. That's not good for the institutions. That's not good for department. Okay, so what we used to do before, it was paper. Okay, so I distribute the paper. You do it. It was the participation was much higher than what we see now. Okay, so it's good for our department to write. We take the evaluation seriously. You may think no one is going to look at this. That's not true. We want to make our department better. So I'm not only talking about this course, but also the other courses. It's going to take few minutes from you, but it's important for us. So if you think in one course, you learned it very well, and this course was okay. You have to give credit for the course. If you have any opinion, if you have whatever. So again, the participation is important in general. Anyway, so let's focus on the topic here. So as I told you last time, guys, we have here microcontroller. Inside the microcontroller, we have a circuit. This circuit, we call it timer system. And I told you before, the main idea is that we have a computer system here. So we have microprocessor, we have RAM, we have input, output. This is a computer system. On top of that, we add some circuits here, like serial communication, analog to digital converter, pulse width modulation. We have other circuits here. The reason we add these circuits because I want the microcontroller to do to use it in big application. Why? As I said multiple times, because most of the work are going to be done by these circuits. So, for example, when I explained SCCI is too complicated. There are too many things. However, if you look at the programming was very trivial. You just have interrupt, go to the interrupt, you are going to get the value you received from the other side. That's very trivial, very easy. Why? Because most of the work has been done by the hardware here. Microcontroller just to go take the value and that's it. You understand what I'm saying? That's how using microcontroller we can make big applications. Same thing for the same idea for the timer. The timer can do very difficult job, but it's going to be very easy from the microcontroller, as you will see right now. Okay. Anyway, so we have here what I'm saying. The timer system, guys. The timer system, as I told you here, we have 80 channels. Every channel has one pin on port T, as you see here. Every channel has also one interrupt, as you see here. Okay, so every channel has one pin. It can trigger one interrupt. Okay, and every channel can work as input capture or output compare. This one or that one. Okay, how you can select. You can program, right? Similar, as I said before, if you have a pin, you can program this pin input or output. It's the same thing here. You can program. Again, that's a good because we're going to have flexibility. If you need all of them input capture, or anyway, so you can program it and you select what do you want to do here, input capture or output compare, as you see here, okay? So on top of that, I told you we have here also a counter, 16-bit counter, only one, not 8. We have a number of registers. I'm going to explain them shortly. And also this counter as well is going to trigger interrupts. We call it timer overflow interrupts. Okay. So let me, yeah, that's what I told you here, guys. So we have here for the timer here, this is how it works. It's like a counter or timer, whatever you want to call it. So that it's 16-bit. So this counter should count. Just count, right? So as you see here, so it is 16-bit, 0, 1, 2, 3, 4, 5, 6 until 1, 1, 1, 1. Is that okay? After 1, 1, 1, it's going to go to 0, 0, 0 again. And at this moment, we call it overflow. That's why we trigger overflow here. We trigger overflow here. Is that okay? So the idea here, the timer or counter, whatever you want to call it, it's a logic circuit. This logic circuit, we have to input here a clock to work. In order to work, we have to input a clock. Okay, a clock means like a square wave this way. Why you do that? Simply because this is how the hardware is going to work. For every cycle here is going to be incremented by 1. Is that okay? So simply by controlling the frequency of this clock, I can control the speed of the counting. Is that okay? Okay. Now, let's understand. So now there are many questions. Number one, okay, so why you need this counter? Okay, I'm going to explain why. Okay. Also, why you need this overflow here? Okay. So it's automatically all the time it's counting 0, 0, 0 until 1, 1, 1, 1, and then from 1, 1, 0, 0, 0 again to 1, 1, 1. It should be as long as the timer is enabled, it should count this way. Okay. Also, if the frequency of this signal, if that frequency is f, that means the time for each count here should be 1 over f. The time for each count 1 over f. Why? Because as I told you, for every clock here or for every interval is gonna count by 1 or incremented by 1. Is that okay? So number one. So let's see. So here, this timer, so the first question is, so is that clear? Any question? Okay, so the first question is, how can we control the clock here? The clock that's used for counting. How can I control it, or is that fixed? No, you can control it. How? Very simple. So the clock here, guys, is, as you see here, it's our clock, the system clock, which is 24 megahertz, as you see here. And then I'm gonna divide it by what we call prescale. Okay, I'm gonna divide it by prescale. This prescale can be 1, it can be other values. So it can be 1, okay, or other values. This is something you can control. So whatever you want, the speed of counting, okay? So, and then, and this is the clock, I'm gonna use it for counting. Is that okay? So number 1, what is prescale? Very simple. Prescale, it's a value, you put it in a register. So this is configuration, similar to interrupts I explained to you before. You need to do configuration, right? And then you need to program the interrupt or use the interrupt as I explained to you before. So this is just as I'm gonna mention right now, as you see here, guys, we have a register. Yeah, we have this register here. We call it TSCR2. This is the name of the register, as you see here, guys. I'm gonna use these 3 bits for prescale. Very easy. As you see here in the table here, look at this table, guys. So if I put here 0, 0, 0, that means the prescale is 1, right? Again, so here's the prescale. So the frequency of the timer is 24 megahertz divided by prescale. Is that okay? So very, very easy. Just you have 2, you can have 4, 8. So based on the value you put here, this is the prescale I'm gonna get. Any questions? So this is the first thing you have to do for configuration. Any question, guys? Okay. So another thing here. Okay, now you told us, I said it last time, but I'm gonna repeat it quickly. We have here, this timer is used. Okay, this timer is used in case of input capture, or usually I'm gonna use the timer to do input capture, or I'm gonna do it output compare, okay? So what is, and again, without the timer system, can I do input capture and output compare using the CPU without the timer system? So the answer is yes, you can. However, it's gonna take too much time from the CPU. And the beauty here is that I'm going to take very little time from the CPU because all the work is going to be done by the system. Same thing for serial communication, right? I can do it using the CPU. However, it's going to take too much time from the CPU. That's why I just delegate it. So hardware circuit is going to take very little time from the CPU. That's why it's very beautiful. That's why we can make big application. Anyway, so what is input capture? As I said last time, very easy. Input capture, guys, means, look here, I have a signal like this one. I want to measure the time from here to here, input capture. Don't think about it. If you want to measure the time, input capture, okay? How can you measure the time? Okay, I'm going to tell you how. I told you we have here a counter, okay? This counter should count from 0 until 65,535, which is 1111, and then count again from 0 until 65,535, should count this way, okay? Let me give you a very simple example, okay? What happens is that you have external pin. So this signal has to be connected to the pin. This is number 1. The signal I want to measure should be connected to the pin. This is number 1. Number 2, what happens is that every time here, if you, I can program the pin to trigger interrupts every rising and falling. For example, this is something you can program. So what happens here is when rising comes to the pin here, 2 things should happen. Let me have a very good picture here. Yeah, look, this is how input capture works. Look here, guys. Every time there is an event on the pin, you have a pin. Every time there is an event on the pin, and this event can be rising, it can be, falling, rising, it can be both, falling or rising. This is, again, this is something you can program, similar to IRQ. This is something, but in case of IRQ, I had only 2 options. It can falling or 0 level, right? This time I have 3 options. So falling, rising, and both, okay? I can program it using registers, as you will see. Anyway, so every time there is one of these events, what's gonna happen is the value of the timer, which is stored in register, we call it TCNT. So TC and T give you the current value of the timer. What is the current value? TC and T. Anyway, so this value TC. So every time there is one of these events, okay, depends on which one you select. Programming. Anyway, so if I program it only for example for falling, so every time there is a falling, two things are going to happen. Two things, as you see in this picture. Number one, interrupt is triggered. It's number one. So every time there is a falling, interrupt. Similar to IRQ. IRQ, every time there is rising, falling, interrupt. Same thing here. But here, in addition to IRQ, there is another thing. Okay, what is that? The value of the timer here, the current value of the timer is going to be stored in a register. We call it TC. This TC, we have 8 TCs. 1 TC for each channel. So we have TC 0, we have TC1, TC2, and so on. So TC is a 16-bit register. It should capture, it should store the current time. What is the current time? From the timer here. Is that okay? In the register, we call TC. So let me summarize it. Very easy. Every time there is an event, number one, similar to IRQ, interrupt is triggered. Okay? I'm going to tell you why I need interrupt, but it's similar to IRQ. Number two, okay? The value of the timer is going to be stored in a register. I'm going to call it TC. Is that okay? So this is how it works. So how this can be used to measure time, I'm going to tell you how. Very simple, very easy. Look here, guys. For example, I'm going to have interrupt here at this time. I'm going to have another interrupt here. So I'm going to have two interrupts, one here and one here, okay? In this interrupt, TC, for example, I'm going to use TC2, for example, but it depends on what channel. We have 8 TC, as I said. So for example, TC2 was equal to 5, for example. That means the time here was 5. That means this rising came at the time 5, okay? Or at the count number 5. Is that okay? Here I found that TC is equal to 9. For example, I'm just giving any numbers, okay? For example, 20, okay? So that means this one, the second one happened here at 20, right? That means from here to here, the counter counted from 5 to 20. So how much is this time? How much is this time? This time should equal to 15 counts. That's why we need a counter here. So here I'm going to use the counter to help me to measure time, right? So here I'm going to measure the time in terms of, counts. How many counts? Is that okay? Then, after you know the number of counts, it's easy to convert to time. You know why? Simply because I already know, as I explained here, I already know the time for each count is 1/f. And I already know f because I already programmed the prescale. So I already know how much time it needs to make one count. So if I know from here to here, the timer counted 5 times, that means the time should equal 5 times 1/f. Is that okay? That is how it works. Great. So now I want to answer 2 questions. The first question is, why we need interrupt here? Why we need interrupt? Simply we need interrupt because I'm going to have here interrupt. So here, I have to store TC somewhere, because if you don't store TC2 somewhere, 20 is going to be overwritten on TC. So we're going to lose it. You understand what I'm saying? That's why I need interrupt here. So inside this interrupt, as you will see in the program later, inside this interrupt, I'm going to say TC2 should store in a memory location, for example, right? Because this is the first value. If you don't do that, when the second one comes, it's going to override the register. Is that okay? This is the first question. Okay, anything here before I continue? Okay, the second question is, I just give you a simple example. Okay, here, okay, let me clarify what I want to say. I just give you a very simple case. The simple case is, look here. I assume I'm going to start at 5, I'm going to end at 20. This is a very simple case. In reality, it may happen that, so for example, if I have 5 and 20 in this case, all what you have to do, you have to subtract. 20 take away 5 should equal 15. Is that okay? However, what if the signal is bigger? If it is big, for example, if I start here, I'm going to start here from, I'm going to delete this one. So I'm going to start here from 4, and then I'm going to go all the way. I'm going to end at 2. You got what I'm saying? So because it's a long time. So what happened, because it's long time, I counted from 5 until 65, 535. Then I went to 0 again, count another 65, 535, went to 0 again, and then the second one came at the time 2. If you do subtraction, you will find 5 take away 2. That means it took minus 3 counts. Doesn't make any sense for sure. Okay, any questions? So in this case, how I can correctly get the number of counts in this case? Okay, I'm going to tell you how. Very simple. So as I'm going to explain later, guys, that is why I have to take into account, I have to consider how many overflow interrupts I had here. That is why we have another interrupt here. We call it timer overflow. Okay, so let me say it again. So in this case, in order to compute the number of counts, I need 3 values, not 2. I need 3 values. The first value, the count at this moment, which was 2. Number 2, I need the count at this moment, which is 5 and 2. Is that okay? Is that enough? No, it's not enough. Number 3, I need to know how many overflow happened. Is that okay? And using these 3, I can make an equation easily, as you will see later, to calculate the time. Okay? Why? Because if I make if you make a complete cycle, this should be, I have to add 65, 535. I have to add it. Is that okay? So anyway, so as you see later, I need 3 values. Okay? The beginning and the end count. Okay? Number 3, the overflow. Any question? So now you should understand. If you didn't understand it, tell me, let me know. You should understand. Number 1, what do you mean by we measure time? I'm going to measure time in terms of counts. How many counts? This is number 1. Number 2, you should understand how the timer is going to be used with input capture to measure time. Okay? You should understand why you need interrupts. You should understand why you need overflow interrupts. Is that okay? Any questions? Okay. So this is for input capture. Now let's talk about output compare. As I told you last time, guys, output compare is used for something completely different. Output compare is used if you want to generate a square wave efficiently, because already we in chapter 3 we already generated a square wave, but this time we're going to generate a square wave efficiently. Is that okay? Also, the counter is going to help me as well this time as well. Okay, I'm going to tell you how. Okay, so the idea is that in chapter 3 we took almost 100% of, as I explained last time, 100% of the time from CPU to generate the square wave. This time I'm going to take a very little time from the CPU. I'm going to have 1 interrupt here. So 1 interrupt here, 1 interrupt here. That's all what I need. So I'm not going to take too much time from the CPU. Okay? How it works, and same thing, how the counter is going to help me to count this time. I'm going to tell you how. Okay, guys? Let me give you, I'm going to tell you how, but let me here, I have very good slide to explain how output compare works. So if you look at this slide, guys, in output compare, number 1, I have to see what is the current. For example, I have to see what is the current count. If the count right now, we add number 1, we add the count number 1. Okay, then I'm gonna store here a value in the future. For example, I'm gonna put here 900. So right now, currently I'm at 1, right? Then I'm gonna put value in the future in TC. This time I'm gonna write to TC. I'm not gonna read. I'm gonna write. Okay, I'm gonna write 900 in TC. Is that okay? Then what happens, the counter is going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 900. Once it comes to 900, two things are going to happen. Okay. Number one, interrupt. Number two, action is going to be taken on the pin. Two things. Is that okay? This is how it works. Okay. Number one, I'm going to put in TC value in the future. I'm going to see what is the current count, right? Then I'm going to put value in the future. Then what's going to happen here? Once I'm going to put a value in the future so that I want a signal to toggle after this number of counts or after this time. Is that okay? So two things are going to happen. Interrupt is triggered. Number two, action is taken on the pin. And this action, you can program it. You can say, next time, I want the pin to be 0, or I want the pin to be 1, or I want to toggle. This is configuration. This is something you can select. As I'm going to explain right now, there is a register. You can select what action you want to do, right? You want the pin to be 0 after 900 counts, or you want the pin to be 1, or you want the pin to toggle. It's up to you. This is something you can program in. So let me explain the idea. Very simple. Look here, guys. For example, assuming I'm gonna do toggle. So the action is toggle. Okay. Look how it works. Number one, I'm gonna assume here. I want this time to be 300 microseconds, for example. Okay. Now, I'm going to assume every count should equal 1/3 microsecond. Is that okay? You have to convert the time to number of counts because this is the currency. This is the language you are using. We're not going to use the time. We're going to use number of counts. Is that okay? So now I have the time, so I have to convert to number of counts. So what I'm going to do now, yes, if you want to make 300 microsecond, you have to divide it by the time of 1 second, one count. So this should be 900 counts. So that means from here to here, the timer should count 900 counts. Is that okay? So what I'm going to do, guys, look how it is interesting, how it is too simple. It's too simple to generate this signal. Look, I'm going to take very, very little time from the CPU. So what I'm going to do, guys, here, inside the interrupt subroutine, I'm going to write inside the interrupt subroutine, TC, for example, TC 0 or 1 or 2 or 2, whatever. Okay. TC should equal TC in T. What is TC in T? TC in T, this is the current count, the count right now, plus 900. That's it. That's it. What this means. So that means when I say TC 0 is going to be TC in T. TC in T means the current count plus 900. It means after 900, toggle the pin and to also trigger another interrupt. Okay, very interesting. So that's using only one statement, I can generate this signal, right? So, and then after, in the second interrupt, I'm gonna move TC 900 more, right? Toggle after 900, right? So, and then in this interrupt, I'm gonna add 900 more. So every interrupt, I'm gonna add 900. You count to the 900, you toggle the pin, and then add 900. You count, toggle the pin, and so on. Okay, any question, guys? For sure, you can make here, just to make it simple, I'm assuming the time here is equal to the time here, but it can be different as we did so you can generate a signal, something like that. Okay, in this case, if it is high, for example, so now I'm gonna say TC equal TC in T, for example, plus 100. However, this time, I'm gonna say TC equal TC in T, for example, plus 900, for example. You got what I'm saying? It doesn't need to be the same, but I need to know, because it's just in one interrupt subroutine, I have to know if this is high or low. So if this is the signal for high, so I'm gonna say, I'm gonna use this statement, else use this statement. Any questions? You understand the idea? This is the most difficult part because everything I'm gonna teach right now is just very simple. What I'm gonna teach right now, guys, is number one, how can you use interrupts? We already explained many times. All the configuration you have to do, you just write some values to registers. We have done this, okay? So any questions? Okay, So you should now understand what is input capture, output compare, how it works. Also, I want to tell you something very important. Last time also I told you guys, input capture, you can use it, and I'm going to explain a program to do that, like IRQ. I told you output compare, I can use it like RTI. Okay? If you don't want input capture to measure time, you can use it like IRQ. How we can do that? I'm going to tell you how. Look here. What is input capture? Input capture means two things. Number one, every time there is an event, and I told you event here in this case, it can be falling, it can be rising, it can be both, and you can program it, okay? So every time there is an event, interrupt is triggered. There is an interrupt, right? Number two, the count is stored in TC. This is what input capture is doing. Input capture is going to do two things. Every time there is an event, interrupt plus the current count is stored in a register. That's it. Okay. What is IRQ? IRQ is this one, right? IRQ is this one. IRQ, every time there is an event, there is an interrupt. Yes. That's why I can use input capture like IRQ, and just I ignore this one. I'm going to ignore TC. Yes, you put the value of the count, you put it in TC, but I'm not going to use it. I don't need it. You understand what the idea, guys? That is why I can use input capture like IRQ. I don't care about the time. All what I care about, every time there is an event, I need interrupt, and this is IRQ. Is that okay? Is that clear? Okay, the other thing, I told you output compare, it can be used like RTI. How? I'm going to tell you how, okay? The idea is that, what is RTI? RTI, as I explained before, periodic interrupts. Periodic interrupts. Is that okay? So periodic interrupts means, for example, I need interrupt every 10 milliseconds or whatever. So every 10 milliseconds, I need interrupt. Okay. And what is output compare? Output compare should be used, number one, to trigger interrupt in the future. In the future. You remember when I told you I'm going to put TC here, TC in T plus 900, right? So that means after 900 counts, I'm going to trigger interrupt. So output compare is used if you want to trigger interrupt in the future, plus two things, plus action on the pin. Okay, as I told you, I want to toggle the pin. I want to like the pin high, the pin low, and so on. Is that okay? Two things. Okay, so what is RTI? RTI should be interrupt in the future. So that means I can use output compare to act as RTI. I'm going to ignore this one. I'm going to ignore this one. Or one of the actions I'm going to teach right now, it's called no action. So I told you we have actually 4 actions, as you will see right now. Number one, the action can be you want the pin to be low. You want the pin to be high. Number 3, you want to toggle the pin. Number 4, no action. So I can use no action. So no action on the pin. Okay. So that means, let me clarify here, guys. Look here. And I told you, if you remember from chapter 4, I told you in chapter 5, I'm going to teach another RTI. I love this RTI more than what I taught in chapter 4. Why? Because this one, very flexible to set the time out. You remember one of the main problems in RTI, to set the time out, we have very limited flexibility because all what you have is just a table. You have to select from this table. I'm going to tell you now something very, very interesting. I'm going to tell you how. Look here, guys. Here, what I'm going to do is that I told you, for example, I'm going to assume the clock I'm going to use for the counter, I'm going to assume it is 3 microseconds, for example. So that means the time for each clock 1/3 microseconds. Sorry, it's 3 megahertz. Okay, so that the time for each count is only 1/3 microseconds. Is that okay, guys? Look how it is. Look how it is very interesting. Look here. All what I'm gonna do, guys, is that if I need interrupts, for example, every 300 microseconds. I need, this is a time set. You remember 130, 10 millisecond we used in RTI. I want to do the same thing, but I want to use 300 microsecond. You have to convert the time to number of counts. Okay. So now I'm going to divide 300 microsecond. It means over 1/3 microsecond. So that means it should be 900 counts. Is that okay? So all what I'm going to do, very simple. All what I'm going to do is that in the output compare interrupt subroutine, I'm going to say TC should equal TCNT plus 900. Is that okay? So that means this is TCNT is here. I'm going to say, please interrupt after 900. Okay? 900 counts are going to be equivalent to 300 microseconds. So this one is going to count 1, 2, 3, 4 until it is equal. It's going to trigger interrupt. In the interrupt, I'm going to say again, I'm going to move TC again at 900. Okay? So next interrupt after 900. Add 900. Next interrupt after 900. Is that okay? This is how it works. Very simple, very easy. Why it is beautiful? Why it's very interesting? Simply because, look, I can increase this time very little by 1/3 microsecond. For example, if I say 901, I'm talking about the time out. I'm talking about the time out, the time for interrupts. I can even increase it a little bit, right? So I have much more flexibility than what we did in RTI. That's why I'm saying this one it's more interesting than RTI. You understand what I'm saying? So you have all the numbers. You can control it much better than what we did in RTI. All what you have to do just you use this number, okay, just to control the time out. Any questions? Is that okay? Okay. Now, this is the most difficult part. Once you understand it, the coming part, just repeat most of it similar to what we did before. Okay. So this is a program I'm going to teach later. So in this program, I want to generate a signal like this one. Okay, guys. As I told you, here we have 300 microsecond. However, we have here 700 microsecond. Is that okay? So number one, you have to convert the time to number of counts. This is the currency. This is the language you are going to use. Okay. So now I'm going to divide this one by the time of one count, which is 1/3 microsecond. So that means this one should be equivalent to 900 counts. And this one equivalent to 21 counts. Is that okay? That means, very simple, look here, guys. That means in the interrupt here, I'm going to use this statement. I'm going to say, please, next toggle after 900. Is that okay? However, in this interrupt, I'm going to use this one here. Very easy, very simple. Is that okay? That's it. So I need to know if I am here or I am here. How can you know? Very simple, similar to what we did in this course in several places, similar in the keypad, when we used the keypad, okay? If you are in line 1, go to line 2. If you're line 2, go to line 1. Same idea. So here I'm going to use a variable. This variable has two values, for example, 0, 0, and FF. So 0, 0 if it is here, FF it is here, and so on, as you will see right now in the program, okay? So that's what I'm going to write inside subroutine. If I am here, so I'm going to use this statement. If I am here, so I'm going to use this statement. Is that okay? Any questions? Very interesting, because try to see how much time I'm going to take from because this is the most important thing. How much time I'm going to take from the CPU? Almost nothing. I'm going to go to the subroutine. In the subroutine, I'm going to execute just a very few, so I can generate a square wave with taking very little time from the CPU. Okay. Anyway. So now I'm going to talk about any questions so far about the main idea. Okay, guys. Anyway, so let's go to the programming. As I told you in the programming here, what I'm going to do, number one, configuration. And configuration is very trivial, similar to what we did before. I'm going to explain some registers, and then I'm going to tell you put the values in this register to program this one, input capture or output compare, and to do the configuration. Just register, you write some values. That's it. The second part is how can you program interrupts, and also this is similar to what we did before. Just we're going to change numbers, as you will see right now. So anyway, so number one, I'm going to talk about the timer. Okay, for the timer, if I want to program the timer, how I can program it? Okay, number one, for the interrupt for the interrupt of the timer, yeah, I have to use this one. We have used it many times before. Is that right? You have to use this one. However, you have to use this number. Before in IRQ, remember, we use this number. For RTI, use this number. However, for here, you have to use this number. That's it. Okay? Very simple. Number 2, for the timer, before I continue, any interrupt subroutine, as I mentioned before, I have to tell you what is the enable bit. We agree on that. Okay? Same thing I'm going to do right now. I have to tell you what is the flag bit. The flag bit you have to clear, right? Similar to what I did before. I will repeat it again here. Anyway, so also, so number 2, for the timer, how much is the clock? How much is the speed? As I told you, so we have this register here, guys. So you have to write some value here in these 3 bits in order to control the prescale. Remember the prescale? The prescale, so we have 24 megahertz. I'm gonna divide it by the prescale, and this will be the clock. It's gonna be F, the clock F. I'm gonna use it to run the timer. Is that okay? So you have here, you have 1, 2, or 4, 8. So this is all what you have as values, okay? For sure, 1, that means it's gonna be too fast, okay? 128 is gonna be slow. Counting is gonna be slow, okay? Anyway, so this is one thing you have to do in this register. Also, as I told you, as I have just said right now, because we have interrupts here, we have interrupts. So there should be an enable bit, enable or disable overflow interrupts, okay? This is the bit you can use for enable or disable. So here, if you put 1, you enable interrupts. If you put 0, you disable interrupts. Is that okay? If you disable interrupts, it doesn't mean the timer is not counting. No, the timer is counting, it's counting, but when the timer overflows, when it is overflows from 111 to 000, it is not gonna trigger interrupt. Or let me be more accurate. Even if I'm gonna discard the interrupt, so even if it trigger interrupts, we're not gonna serve this interrupt. Okay. So when it triggers, but it can be counting. Okay. There is another bit, as you will see right now. Do you want the timer to run or not, count or not? This is another bit. Okay. But anyway. Yeah, this is a bit I'm talking about in this register TSCR1. This bit here, guys, this is, do you want the timer to count or not? If you put 1, that means the timer is functioning normally, it's counting, right? However, you can put 0. 0 means the timer is not counting. And usually, think about it. If the timer is not counting, I can't use input capture, I can't use output compare for sure, because input capture, output compare depend on the value of the timer. So if the timer is not working, that means input capture, output compare is not working for sure. You sometimes, I think the reason we may need something like that is, as it is written here, if I want to save the power consumption. What this means? It means assume I don't want to use the timer. Okay, so if the timer is counting, so I'm gonna consume energy, right? Especially if you have a system, you run the system using a small battery. So in this case, it may be better if you don't. So anyway, so normally if you want to use the timer, you have to put here 1 in order to count. Normally, you have to put 1 here to enable the interrupts. You have to put a certain value here that can reflect the speed of the counting. That's just very easy. What else do you have here? Yes, we have the flag bit. I told you for any register, we have to explain the flag bit. So this is the flag bit as you see here. Okay. So in the interrupt subroutine in this register here, you have to write 1. You have to use this one in the interrupt subroutine to clear the flag bit as we did before. You have to do it. Okay. Do you have anything else? No, that's all what we have. Okay. I just put everything here in one diagram. So what we have here, this is the clock, and this one can control. Do you want a counting or not? So if you put here 0, I'm gonna get 0 and no counting. If I put here 1, so I'm gonna get here a clock. This clock, I'm gonna divide it by this value. This is 24 megahertz. I'm gonna divide it by this value. Then I'm gonna input it to counter to count. Okay. When you count, this is the name of the register. the value, if you want to get the current value for counting, TCNT, right? 16-bit register. Anyway, and every time after, when it counts 65, 536, after when it counts from 000 until 11, it's gonna put 1 here to trigger interrupt. Is that okay? This is a flag bit. This is the bit you have to clear. Is that okay? Then you are gonna trigger interrupts if 3 conditions are true. 3 conditions are true. Number 1, CCR. You remember CLI I explained before. This number 1. Number 2, this bit here. This bit to enable interrupts. So if all interrupts are enabled, there should be 0 here. If all of them are enabled, right? If you enable this interrupt, there should be 1 here. And every time the timer here wanna trigger interrupt, is gonna put 1 here in the flag bit. If this is the case, you are gonna trigger interrupt. Is that okay? So there should be 3 conditions as I explained before. This is a global, this is a local, this is a flag bit. Anyway, so here I just summarize. If you want to use the timer, what programming you have to use? Very simple. So number 1, you have to use this one, guys. Number 2, you have to put here 80 in this register, TSCR1. Let's see what is this register, TSCR1, which is this one. 80 means you have to put here 1 and 0, 0, 0, 0, 0 in order. So you have to do this one. So that's what I did here in this command. Okay. We have another command, this register. This register, let me come here. Yes. Here, you have to put for sure 1 here, right? To enable interrupts. And then you have to put value here for the this one. Okay. So again, only 2 until now. It's only 2, right? So yeah. So as you see here, guys, to do the configuration for the timer, you have to write some values to 2 register in the main program. That's it. That's it. Once you do this I'm done. In the interrupt subroutine, you have to write this one to clear the flag bit. Okay, guys. Any questions? Okay. This is for the timer. Now I'm gonna explain how can you program input capture, output compare. Again, I know you may be like overwhelmed with the number of registers, but just very easy, right? Because too many registers. But anyway, it's just very easy. Okay. So now I'm gonna go to how can you program input capture, output compare. Okay. So if it is either input capture, output compare, it doesn't matter. So you have to write this one, right? This is you have to initialize the interrupt vector. We did it very long time ago, right? So we do it all the time. I started it very long time ago. Anyway, but you have to use the number here. So if you want to use a channel 0, you have to use this one, channel 1, channel 2, channel 3, channel 4, or you can use more than 1. I didn't say you can only use 1 channel at a time. You can use all of them, right? So for every channel, you have to use 1. Remember, in the test, we used IRQ and RTI, and we wrote 2, right? We wrote 2, 1 for IRQ and 1 for RTI. So you have to write 1 for every interrupt. So if you use 10 interrupts, you have to write 10 of this statement. Okay. Number 2, I told you every channel can be used either input capture or output compare, right? This is something you can select, you can program. How I can do it? Very simple. We have this register. So we have a register here. This register is called TIOS, right? So this register, it has 8 bits, as you see here, 8 bits. Every bit is gonna program 1 channel, input or output. Very easy. 0 or 1, very easy. You got what I'm saying? So here, guys, we have 80 channel. Every channel can be programmed input capture or output compare. How I can do that? 8 bits, 1 bit for every channel. Okay, very easy. So for example, here, guys, this is for a channel 0, a channel 1, channel 7. Okay, so we have 80 channels. All what you have to do, if you put here 0, it means it is input capture. So if I put here 0, that means I need a channel 0 to be input capture. If I put here 1, so channel 7, please, you should work as output compare. And that's it, very simple. Is that okay? So every channel, you can program it independently, right? As you see here, very trivial, very easy. Is that okay? So here, how I can write to this register similar to what we did before. If any instruction I taught before for memory location, you can use it right now, like move, like bit set, bit clear. Okay, again, nothing is new. Any questions? So this is the first thing you have to do. So in the configuration, I have to write one statement, one instruction about input capture or output compare. You have similar when I configured every pin input or output pin or input pin. Okay, same thing here. This is number one. Number two, now we have 8 interrupts. You told us every interrupt should have enable bit. I have to tell you where is the enable bit, right? To enable or disable interrupts. Yes, where it is. The good thing, we need 8 enable bits, 8, right? Because one for every channel, we need 8. So the 8, they put them together in one byte. That's it. So now this byte is called tie, T-I-E, tie. Timer interrupt enable register, tie, right? So this register, it has 8 bits as you see here, one bit for each channel, okay? As you see here. So for example, this is channel 0. If you want to enable interrupts of channel 0, just put 1 here, enable interrupts. If you want to disable channel 0, just put 0 here. Is that okay? Very easy, okay? Number 2, what else? What else? Think about it. I told you also for any interrupt, I have to tell you where is the flag bit. The flag bit, same thing. Now we need 8 flag bits, 8, right? The 8 bits are in one register, as you will see right now. Yeah, this one, interrupt flag bit. They put the 8 in one register. Very easy. So all what you have to do, guys, so this is for channel 0, channel 1, channel 2, channel 3, and so on. All what you have to do, if you want to, you have to write here 1, if you want to clear the flag bit, this flag bit, or you have to write here 1, what depends on which one you have to use. And you have to do this, in the interrupt subroutine. Is that okay? What else here? Okay. Only two things are left. Okay. In case of output compare or in case of input capture, okay? In case of input capture, I told you when do you want to trigger interrupts? I told you we have 4 cases, okay? I can trigger interrupts when at falling, at rising, at both. So every time there is rising or falling. This is similar to what we did, exactly same thing, what we did in IRQ. However, in IRQ, we had only two options, either falling or 0 level. So you remember? So that's why you put 1 or 0, right? 1 for this one and 1 for this one. However, here we have 4. We have 4 selection. One selection here is falling, rising, both. So the pin, every time there is a rising or falling, in both cases, you are going to trigger interrupt. Okay. Number 4, okay. Number 4 is going to be capture disabled. So it's no capture. Okay. So anyway, so now, now we have 4 selection. That means to say 4. It means I need 2 bits, right? Because if you have number 4 can be represented in 2 bits. That means for every channel, I need 2 bits to select a number from 0 to 3, right? 4 numbers, okay? So, and that's exactly what we did. So what we did here, guys, as you see, now I'm not one register. So again, let me say it this way. We have 80 channel. I need 2 bits for every channel. For each channel, I need 2 bits. Why? Because I have a number from 0 to 3 because I have 4 selection. You remember in IRQ, I needed only 1 bit because I had 2 selections. But anyway, so in total, now I need 16 bits in total. That's why I'm not going to use 1 register. I'm going to use 2 registers, as you will see right now. So now, as you see here, guys, I'm going to use 2 registers. The first register is called TCTL4. The other one is called TCTL3. Okay. So here I'm going to use these 2 bits for a channel 0. I'm going to use these 2 bits for a channel 1, a channel 2, a channel 3, channel 4, 5, 6, 7. Very easy. Is that okay? All what you have to do is, look here, guys. If you want to program it, if you want to capture rising only, you have to write this way, 0, 1. Capture only rising only. Or you can capture falling only. In this case, you have to write this number. If you want to capture both, you have to write 1, 1. So if you want to capture both, you have to write 1. Okay. If you don't want to capture anything, you just put 0, 0. Okay. Anyway, I don't think we're going to need 0, 0. So all the time should be, you want to capture this one or both. Is that okay, guys? Very easy. Any questions? I know There are too many registers, but it's just easy. Okay, so I'm gonna summarize them later. The last thing, the last configuration you have to do, this should be for output compare. I told you in output compare, I told you if this is TC in T, then I'm gonna put value in the future in TC, right? So this one is gonna count. Once they are equal, action has to be taken on the pin. This action, you can program it. We have 4 actions. So after 300 microseconds, what do you want to happen to the pin? You want the pin to be low, you want the pin to be high, you want the pin to toggle, or no action on the pin. Don't do anything on the pin. If it is high, leave it high. If it is low, leave it low. Is that okay? So now, same idea. We have 4 selections, 4. That means I need 2 bits. The same idea, I need 2 bits, right? So here, in order to select one of the 4, that means I need 2 bits times 8 channels, so I need 16 bits, okay? So now I'm gonna use 2 registers, as you see here. This is 1 register, this is another register. As you see here, guys, these 2 bits are for channel 0, 2 bits for channel 1, channel 2, channel 3, 4, 5, 6, 7, okay, guys? So 2 bits for every register, and it's very simple. All what you have to do, guys, you have to write one of these values. For example, if I'm using a channel 0, make it very easy. I'm going to use a channel 0. Okay. So what do you want? If you want to toggle, every time, if after a certain time I want to toggle the pin, all what you have to do just to put 0, 1 here. That's it. Okay. This 0, 1 here. Or if you want to clear, if you want to make the bit 0, if the pin 0, so I have to put here 1, 0, and so on. So, okay, guys, or you put 1, 1. Any questions? Okay. So now, yes, I know you may be confused because too many registers, but it's very easy. Just some values you put it, right? So that's why here I summarize everything here. Everything you have to do, I summarize it here. Okay. It's not too many as you see here, but I'm going to tell you what I did here. Look here, guys. So what I did here, guys, number 1, if you want to use input capture or output compare, okay, you have to configure the timer as well, because the timer is used to help input capture or output compare, right? So I have to configure both the timer and input capture or output compare. That's what I'm doing here. For example, I want to program input capture. Okay, guys, for sure you have to use this one. Okay, for sure. Number 2, you have to write here something for the timer. You have to enable the timer, right? As I explained to you before. Number 2, then you remember TIOS. This one you have to select. This is channel 0. I have to select it input capture, not output compare. Okay, I told you there is one register TIOS. This one can control if you want to select this channel to act input capture or output compare. Here I'm gonna say bit clear because I want to put 0, because 0 is gonna make it input capture. However, when I come to output compare, I'm gonna use bit set. Why you are using bit set? Because you want to write 1, because 1 is going to make it output compare. Is that okay? So you have to write this instruction to select the pin input capture or output compare. Is that okay? Also, here you have, in case of input capture, guys, you have to select what do you want to capture. You want to capture rising only, falling only, or both. Okay, that's what I did here. Based on the number, I wrote it here, right? So here in this case, I want to capture rising only. That okay? Also, you have to enable interrupts. That's all what you have to do. Very simple. Yes, I mentioned too many registers, but at the end, that's what you have to do in order to program input capture. Okay? What should I do in output compare? I still need this one in output compare because I still need the timer. That's why you see I put it here, right? Also, I still need this one to configure it input capture or output compare. However, instead of bit clear, I used here bit set, because when I write 1, I'm going to make it output compare. If I write 0, I'm going to make it input capture. Is that okay? Okay, what else? Still, I have to use this one. It's the same thing, like this one, because this is to enable interrupt, same thing. However, instead, I'm not going to use this one. I'm not going to use this register. I'm not going to use it in output compare because this register is only for input capture. This register should control what do you want to capture. Is that okay? I have to use another one which control what action you wanna take on the pin. Is that okay? So this one always you have to use only in input capture. In output compare, we are going to use another register because this one can control the action you want to take. Okay, the action toggle or clear or whatever. Okay, guys. Also, in the interrupt subroutine, you have to clear the flag bit, as I mentioned. Is that okay? This is the same. It doesn't matter. It doesn't matter if you use the interrupt for input capture or output compare. You have to use the same thing here. Okay. Any questions? Okay, great. Now, how I can do the same thing in C language? Similar to what we did before. In C language, you can use the name of registers as same thing like assembly, or you can use subroutines. We have a number of subroutines. You can just use the subroutines to make programming easier, similar to what we did before. So what subroutines you have here, okay? The subroutines I have, for example, you have here one, we call it timer run. Allows the timer to run normally. That means this the last bit here. So this is to run the timer. This one should stop the timer. Okay, this one here. This one to enable the interrupts of the timer, disable the interrupts of the timer. This one to initialize the timer. Here in the initialization, you are gonna run the timer. You are gonna put 0 in TCNT is because you wanna start counting from 0. So in TCNT, I'm gonna put 0 to start counting from 0. Also, you are gonna enable the interrupts. The last thing here, the number you have to send here, this number is gonna be used for prescale. Okay. So whatever you are gonna send here, this will be used to calculate the prescale. Also, if you wanna clear the flag bit, you can use this one. If you want to reset the timer means you're going to start from 0. So you can write this one, or you can just say TCNT is equal to 0. Okay. Now let's look at the channels. Similar to what we did before, just the subroutines. You can just use the subroutines. Okay. So here, for every channel, you have initialization here. In this initialization, you have to send to 2 values, as you see here, 2 values. One value, which is B. This value should tell this is channel input capture or output compare. Okay, so here, if you put 0, here 0, that means you want it to be input capture. If you put here 1, you want it to be input compare. Is that okay? So this is the first thing you have to do. So this value, the value here, 0 or 1. Okay. Also, this subroutine is going to enable the interrupts, and then this value here, whatever you are going to put here, is going to be used in TCTL in order to program what you are going to capture, okay? Or in case of output compare, so this value, in case of input capture, this value should tell, this value is going to be written to TCTL to program what do you want to capture. You want to capture only rising or falling or whatever, okay? Or in case of output compare, this value is going to be used, okay, to tell what action you want to take on the pin. Okay, so every time you want to toggle or you want to do whatever. Like, anyway, so again, also we have here just subroutines like a channel 0 enable to enable interrupts. For every channel, you can disable interrupts. You can also clear the flag bit this way. Anyway, okay, guys. One more thing we used in C language. To remember in C language, when we have to use a certain number when you use interrupt. I don't remember. Used void interrupt, and then we used a number. Do you remember this number? Okay. This number should come from this table, and I told you this number should tell the C language what interrupt is that. Okay. For example, in case you remember, we used the number 6 in case of IRQ. We used the number 7 in case of RTI. Same thing here. So here, in case of a channel 0, you have to use number 8, number 9, number 10. That's it. Is that okay? Just to change the number to tell what this interrupt is for. Is that easy? Similar to what we did before. The only difference before, we just use 6 and 7. Now you have to use the correct number here based on what interrupt you are programming. Okay. Any questions? Okay, guys. Okay. So now. Okay, now Now, in this part here, just I give you word programs. I give you different programs, okay? So technically, I almost finished the timer system, but here I just want to explain how can we use them, right? To make input capture, to make output comparison. Now, I'm gonna focus, I have several programs here. The first, I'm gonna focus mainly on 4 programs. Number 1, how can you use it like IRQ? And it's gonna be very trivial. Number 2, how can we use the input capture to measure time? How can you use output compare how can you use output compare to generate a signal? Number 4, how can you use output compare like RTI? This is the 4 programs I'm going to focus on. You have other programs here, by the way. So here I'm explaining how can we use output compare to make like alarm. Luckily, we already did this one using RTI in test 2, right? It's the same thing, but here I programmed it using output compare, right? So using output compare, we're gonna trigger a signal here. We're gonna generate a signal here. Because this is how output compare is used. Output compare is used if you wanna generate a signal, right? So here, this is the same thing you did in test 2, but in test 2 I used RTI. This time it's already done using output compare. Anyway, so you already have several other. I'm going to teach you this one. How can you use it like RTI, which is very simple. Okay. So anyway, so let's see. Start with the first one here. Here, look here, guys. Now I want to use. I want to use one of the channel like IRQ. Okay. So how I can do it? Very simple. Look here. Very simple. Look here, guys. Number 1, I'm going to use the same program like this one. I'm going to do the same configuration. I'm going to use this program like this one. Same program. Okay. However, so if I use this program, that means every time there is a rising edge, 2 things should happen. Number 1, interrupt is triggered. Number 2, the time TC in T is going to be stored in TC, right? And usually, if you want to measure time, here, I have to write here a command. Okay, now TC, I'm going to store it somewhere. Okay, just because I want to clear it for the second value. Okay, anyway, but here in case of IRQ, I don't care about TC. I don't care about the time. All what I need, every time there is rising, there is interrupt like IRQ. Okay, guys, very interesting because now in chapter 4, I explained 1 IRQ. Now you can have 8 IRQs if you want. Okay. Anyway, so simply I'm going to use the same program here as you will see right now. Okay. And then whatever you want to do here for IRQ, just put it here. That's it. Okay. So let's see here in this example. Yeah, here. For example, here, guys, a switch is connected to pin 0 to make rising edge. When I press the switch, write a program to increment a binary number displayed on the LEDs on port B each time I press the button. So what I want to do here, guys, you have a binary number here. Every time I press the button, I'm going to trigger interrupt, okay, to input capture. This is inside the interrupted subroutine. I'm going to say increment the number in binary. So you're going to see the LEDs counting every time I press. You can see the number in binary. Let's see if I have a video for this one. I hope. Anyways, I think the idea is clear. I don't need to run the video, but let's see. I don't think I have a video, but anyway. But I think the idea is very clear. Okay. So let's see how can you do it, guys. Okay. Number 1 here, you have to do configuration for port B because I'm going to use port B. Okay. You have to enable LEDs. You have to disable 7 segment. Okay, that's very simple. Also, I'm gonna write this part here for the interrupts of channel 0, right? Also, I have to. This is the configuration I did. So you have to enable the timer counter to count. Also, I have to select. This is input capture. I'm gonna capture the rising edge, or you can program it falling. So whatever you want. Also here, I'm going to enable interrupts. That's it. So once you do that, once I do this configuration, what's going to happen is every time on the pin here, every time there is rising, interrupt subroutine is going to be executed. Is that okay? So so now I have a subroutine here. Every time there is rising, I select rising, right? Yeah, here I'm selecting rising. So every time there is a rising, you are going to execute this subroutine. So now, what do you want to do here in the subroutine? All what I'm going to do, as you see here, guys, for sure you have to clear the flag bin. You have to clear the flag bit. You can add the debouncing code here. You can add it. All what I'm going to do, every time I'm going to increment a count, I'm gonna copy this count to port B. So every time you press the button, you are going to trigger interrupt. When you trigger interrupt, I'm going to execute this subroutine. This subroutine is going to increment the count. Just write the count on port B so that you can see the count. Very easy. Okay, guys, any questions? Okay, now, again, this is, I used it like IRQ. I didn't use it to like input capture, which means I didn't use it to measure time, right? Anyway, so this is the C language program. I'm going to talk about it, and then I'm going to see the next program. The next program, I'm going to teach how can you use input capture to measure time, right? And I already explained the ideas. The idea is that I need one interrupt here, and I need another if I want to measure the time. For example, if I want to measure the time from here to here, what do you need? I need 3 values. Now, the first value, what was the count here? Count 1. Number 2, what was the count here? Count 2. Number 3, how many overflows? That's it. So I need only 2 interrupts. Every time I want to measure time, I need 2 interrupts. 1 interrupt here, second interrupt here. This interrupt is going to give me the count here in TC. This one also is going to give me in TC. That's why I have here in this interrupt, I have to store it somewhere. Otherwise, it's going to overwritten, right? Okay. Then after I get these 3 values, I'm going to do like use equation in order to get how much is the time, right? Very simple, very easy, right? As you will see right now. But anyway, let's see the C language here. It's the same program I taught right now for using IRQ. I'm going to explain it in C language. So in C language, as you see here, guys, this is the interrupt subroutine. Here I'm going to use number 8 because this is for channel 0. Okay. So in every interrupt here, I'm going to clear the flag bit, right? I'm going to increment the count, and then I'm going to write count to port B. Very simple, very easy, right? As I said before, and as we did before, count has to be global. Otherwise, you are going to have a mistake here. Okay. This is for initialization. Look what I did here for initialization. You disable 7 segment, you enable LED, you just run the timer, and then I configure channel 0 this way. That's it. So when I configure channel 0, I'm going to use here number 1. You remember, I told you this one can control input capture or output compare. Okay. So this is number 1 for input capture, I guess. And this one should control, anyway, you can go back, already you see how can use it, I already explained, okay? So you can see, so all what you need to do here, guys, just, I'm gonna write these two functions, that's it, okay? Very easy, right? Any questions? Okay, now, I wanna measure the time here, okay? So to measure the time, guys, I told you all what I have to do is, I need 3 values. I need what was the value here? What was the value here? I need the overflow, and then I'm going to use equation. Okay. So what equation you are going to use here? Okay, I'm going to tell you guys. Look here. The idea is that if you start here, for example, if I start here, and then I end here. For example, I'm going to have multiple rounds. For example, and then I'm going to end here. Okay. So what happens here in this case? So if there are 2 cases and they have a little bit different, I'm going to tell you why. So that's why I'm going to have 2 equations right now. Okay. The first case, when H2 means the count in the second, I need 2 counts, right? As I told you, 1 here and 1 here. This is 1, this is 2, right? So here I started here and I ended here. So I moved this way, or maybe I'm going to multiple times and then I'm going to come to here. Is that okay? This is 1 case. Another case, I started here, and then I'm going to go multiple rounds, but I'm going to end here. Is that okay? So 2 cases. 1 case, if the count of H2 is greater than the count of H1, okay? Second case, if H1 is greater than H2. Okay, I'm going to tell you what is a small difference. In this case, look here, guys. This is the time should equal number of overflow times 2 to 16. Number of overflow times 2 to the 16, because every one overflow means I count completely from 0, 0 to 1, 1, 1, 1. So that's why it should be 2 to 16. You make a complete round, right? So the number of overflows times 2 to plus the difference from here to here, plus the difference. Is that okay? So every overflow means I count it completely, right? Plus the difference. However, in case H1 is greater than H2, right? So in this case, it has to be overflow minus 1. It's the same equation here. Look, it's the same equation, but this one overflow minus 1. Why? Because the first overflow should not be counted. The first one should be, why? I'm going to tell you why. Because what happened is that, oops, okay, I'll almost finish. So what happens when if I start here, look here, guys, if I start from here, make here, I'm going to trigger overflow. This overflow should not be 2 to 16. It should not be 2 to 16, the first one, right? So then I'm going to come here, stop here. Okay, that means I didn't make a complete round. This is not the case here, okay? The case here, look here, guys. If I start from here and then go all the way from here to here until I stop here. Yes, this one should be 2 to 16 because you made a complete round plus this part. Anyway, to make it simple, because I think we ran out of time. Okay, to make it very simple, Look here, guys. Again, I'm gonna have 3 values. I need to know what was the count here. I need to know what was the count here. I need to know the number of interrupts. Okay, using these 3 values, I can use this equation or this equation to calculate the number of counts. That's it. Okay, so I'm going to explain it next time. Also, next time, I'm going to focus on pulse width modulation. Don't worry, I know maybe this part I explained it quickly. It's not difficult, similar to what we did before. So I told you in the exam, for the exam, I'm going to tell you if we need anything from here or not. Also, I'm going to tell you if need something, I'm going to tell you I need this program or that program. Is that okay? Because I taught it quickly. But luckily, this part is just similar to what programming wise, same thing as we did before. Anyway.